All right, welcome to the homework 10 solution video. And in this one, we're going to deal with integrating using area and um, using the first part of the fundamental theorem. But first, we threw in this question here in the beginning. And it wasn't something that I explicitly covered exactly this way in the lecture. However, it's basically exactly the opposite of what I had done. So let's take a look at it and see how to parse it out. N 2 plus 4I over n squared times 4 over 5n. Okay, so basically what this is asking is usually we take the limit version. I'm sorry, other way. Usually we take the integral and then translate into limit definition, right? Well, all this is asking is, here is the limit definition, and I want you to write it as an integral. That's all. So I'm given sort of the messier form, and I want to clean it up and write it in this sort of grown-up notation. All right. So let's see how we can do that. Now remember the general form, general limit form of an integral is limit as n goes to infinity of b minus a over n times the sum I equals 1 to n of f of a plus I times b minus a over n. Right? Okay. So what do we need? Well, we have what we want, the integral from a to b of f of x dx. Okay, so the things that we need are, first, we need a and b. Right? We need the interval because we have to be able to write the bounds. And second, we need f of x. Right? We have to figure out what the function actually is, what the integrand is. Okay, and that's it. Right? That's all the information really that an integral holds. But there's a lot more than that floating around here. So we have to sort of write the given limit in this form so that we can pick off that information. Maybe the best way to do this is, let's figure out what is b minus a over n first. Maybe that's a good place to start. Okay, so b minus a over n, it looks like I can rewrite this. So let's do just that. So rewriting, I have the limit as n goes to infinity. And remember, anything that isn't exactly attached to an I can just get pulled outside. So let's do that. Let's pull that 4 over 5n to the outside. And then I had 2 plus, I think it was 4i over n squared. Okay, so this is looking closer, right? I have a b minus a over 5n. Okay, so it looks like 4 is going to be our b minus a, because I can even rewrite this further. One more time, 4 over 5n. Sum I 1 to n, 2 plus I times 4 over n, right? To even match it closer. It looks like this big grouping here is our f of a plus I times b minus a over n. That's what it sort of looks like, right? It's something squared. Looks like our function is going to be x squared. And I have this thing in parentheses. Looks like this is going to be my b minus a over n. Here's my a. And then I have the I floating around where it has to be. The weird thing out here, though, is that this should be b minus a over n. But it's not quite that, right? B minus a over n, it looks like, should be just 4 over n. I have an extra 5 on the bottom. All right, so how do I correct for that? Well, I could just sort of cheat and bring the 1/5 away from the 4 over n. Right? So I have my 4 over n where it needs to be. This is my b minus a over n. And the 5 I can write just as a separate thing. So I'll just write it as one big multiplication here. Ah, 2 plus I times 4 over n squared. Right? Okay, so it looks like we're pretty close. But this 1/5 is still an issue, right? It should be just b minus a over n times a sum, and I should only have the function on the inside with a plus I times b minus a over n. But who says this 1/5 isn't a part of the function? In fact, it is. I can move this 1/5 outside. We know that. That's a trick that we've used for linearity. But that also says that I can move it inside. So I rewrite it one more time as this. And of course, you don't need to write it out in this many steps. If it's clear to you, this is one of those things that it's sort of just, you need to see it, and I'm doing my best to explain my reasoning. But I'm sure in a lot of cases, you guys pretty easily saw at least that the function was going to be x squared of some kind. Maybe it was a little bit more work to see that there was a 1/5 in there, but it looks like this is in the right form now, right? Here's my b minus a over n, as we've said. And then here is my f of a plus I times b minus a over n squared. Oh, sorry, that's just squared. Listen to me. Just f of this, right? Okay, so what does this mean? This means that a is equal to 2 because it's right in the formula. All right, b, there's a little bit more work to do, but I know that 4 is equal to b minus a. And I know what a is. Okay, so 4 equals b minus 2. So what does b have to be? 6. And then finally, what's f of x? Well, it's the whole inside, right? I have it written in this form, but if I just replace this guy by an x, I get what I'm looking for. 1/5 x squared. Take whatever the input is, square it, and then multiply by 1/5. Okay, so finally, I can answer the question, and I have the integral from 2 to 6 of x squared over 5 dx. And that's what that question was asking for. Okay, number 2, we wanted to evaluate the integral from 1 to 4 of x plus 2 dx using geometry. Okay, so the idea is we graph this thing and find the area underneath it within the interval 1 to 4. Okay, this should be easy enough. X plus 2 is a line. That should be clear enough, right? If I write f of x equals x plus 2, or even more clearly, y equals x plus 2. This is a slope or a line with slope 1 and y-intercept 2. So I'll just mark off 2 right here. And the interval of interest is 1 to 4. So here's 4, here's 1. And what I need to do now is find out, where do I start and where do I end? So what I have to do is figure out what's f of 1. That's just 3. Okay, so I come over here. F of 1 equals 3. And f of 4 at the other endpoint, I get 6. So 4, 5, 6. And that's right about there. I connect them. There's my line. Of course, it goes on forever, but I only care about the area underneath it between 1 and 4. So I drop a straight line down, drop a straight line down, and I'm looking for this thing here. Right? Okay, now this is a trapezoid. And if I knew what the area of a trapezoid was, if you know what the formula is, feel free to use it. That's totally fine. No one will ever bother you with that. And I will write those out explicitly so we know. But I don't have that memorized. And I think it's a little bit more difficult to deal with than is necessary. So what I'm going to do is draw a straight line across here. And I'm going to read this instead as the area of a triangle plus the area of a rectangle. Right? If I take the area of both pieces, I get the whole thing. All right, so I need to know the dimensions. So it looks like the triangle piece. I'll draw them out here separately. Has width from 1 to 4, that's of length 3, and has height from 3 to 6, which is also 3. Okay, so area of the triangle is equal to 1/2 base times height, which is 1/2 3 times 3, or just 9 over 2. And now the rectangle, find the dimensions of that thing. Looks like, again, it has width 3, and the height is also 3. Great, how convenient. So I have the area of the rectangle is simply base times height, so it's just 3 times 3, which is 9. Area of the whole thing, or the integral, thus, integral from 1 to 4, the area of the entire thing, is equal to area of the triangle plus area of the rectangle, or 9/2 plus 9, which is 27 over 2. And that's that. Okay, similar problem, but slightly more difficult, I think, although with the hint, it's a little bit easier. I won't write out the instructions again. It's the same instructions as part 2. You guys know that. All right, so we have the integral from 0 to 3 of the square root of 9 minus x squared. Now, the hint gives us that this is the top half of the circle centered at 0 with radius 3. How do we see this if I didn't have a hint? Because on an exam, we probably wouldn't give you a hint like that. So this is the integrand, so f of x equals 9 minus x squared. When we want to read it as a graph, it's convenient to read it as y equals, square root 9 minus x squared. Okay, and now if I want to write this out in something that I recognize a little bit better, this isn't really something I know all that well. I can square both sides. And if I bring all the letters to one side, I get x squared plus y squared equals 9, which is 3 squared. Right? So this is the equation of the circle of radius 3, right? X squared plus y squared equals r squared, where r is the radius. And if I were to do this process backwards, notice that here I'm only taking the positive square root, right? If I got to here and I wanted to take a square root of both sides, I'd have to have a plus or minus here, right? To take care of the top half and the bottom half of the circle, right? But since I only have the positive, I only get the top half. Okay, so I have this. Here's -3. Here's +3. And here's +3. And I'm looking for the area under this curve. Except all I care about, coming back to my bounds here on my integral, is this. Right? Okay, so I'm looking for the area under a circle only in this little quadrant here. And I use quadrant to be suggestive, right? Notice that this thing that I've colored in is 1/4 of a circle with radius 3. Okay, so what's the area of a circle with radius 3? I get pi r squared in general. Area of a circle with radius 3 is pi 3 squared, so 9 pi. How about the area of, if I just had half a circle, it would just be 9 pi over 2, because I would just take the area of the whole thing and divide it by 2, or area of the thing I'm looking for, quarter of a circle, is going to be 9 pi over 4, right? Just adjust according to whatever your bounds tell you to do, right? Just divide by the proper fraction, or by the proper number. Okay, so it looks like the integral from 0 to 3 of the square root of 9 minus x squared dx is equal to the area of the quarter circle, which is equal to 9 pi over 4. And we're done. Okay, moving on to number 4, we're going to talk about the fundamental theorem a little bit, at least the first part. So I want to evaluate the derivative of the integral from -1 to x of sine t minus 1 over t dt. Okay, so remember I need a constant on the bottom and I need an x on the top for the trick to work. And wouldn't you look at that, constant on the bottom, x on the top for this to work. This and this match up. This is a constant, so we're set. All I need to do now is take the integrand, sine t minus 1 over t, and plug in the top bound, or whatever we're differentiating with respect to. So in that case, I get sine of x minus 1 over x, and we're done. All right, on the same page, let's talk about number 5. A little bit more work to do for number 5, because I'm not exactly in the right form yet. 2e to the t plus t to the fourth minus 15 dt. Okay. All right, so not quite in the right form, but we know how to deal with this, right? I can take the integral and split it. So let's deal with the first interval, x to any constant. Let's say x to 0. Why not? 0 is sort of the most convenient thing. 2e to the t plus t to the fourth minus 15 dt. And that is one of them. And now remember, derivatives also split, so I can write it this way. And then once I go from x to 0, I want to go from 0 all the way up to the top bound. So I have my 0 as my intermediate guy. He's sort of the point in the middle. The top guy up here, bottom guy down here. 0 to ln of x. So I can finish off the integral. And I've run out of room here. Let me rewrite this. That plus d dx. 0 to ln of x. 2e to the t plus t to the fourth minus 15 dt. Okay. All right, so now I'm almost there. The one last thing I have to do is make sure that the constant's on the bottom and the x is on the top up here. So d dt, or d dx, sorry. but I can put a negative here to flip the bounds. And now it looks like I'm in the right form. I have to do a little bit of a chain rule at the end, but that's not a problem. Okay. So the derivative here is nice and easy, right? In the first case, I'll separate them by parentheses. I get 2e to the x plus x to the fourth minus 15 plus, and now I plug in ln of x, right? So I get 2e to the ln of x plus ln to the fourth of x minus 15. But this term I have to multiply by the derivative of ln of x, right? Just by chain rule. Okay, so I get 2e to the x, that's fine, plus x to the fourth minus 15. Plus, now e to the ln of x just cancels out to give me an x, so I get a 2x plus ln to the fourth of x minus 15. And then with this thing, I have to multiply by 1 over x. And I suppose you could do one more simplification. I'm going to run out of room here, but I get 2e to the x plus x to the fourth minus 15 plus 2 plus ln to the fourth of x over x minus 15 over x. And I think I can box that without making it too messy. Great. Okay, and that's basically, it's essentially the hardest problem I can ask you in terms of first part of the fundamental theorem. If there's any questions, feel free to email me, and have a good week otherwise.